1.3, day 2. We are still talking about elimination today, so we're going to continue on. We're going to make it a little bit harder, some extra steps here that we haven't talked about yet. Let's start by reviewing the 5 steps that we already know for elimination. I'm going to write them off to the side over here. Step number 1, whenever we start an elimination problem, in order to cancel things out, we have to have opposite coefficients. Opposite coefficients look like the same variable, so either both of the x's or both of the y's. One positive, one negative. They have the same number in the front. Once we have the opposite coefficients, our goal with those opposite coefficients is to add together our 2 equations and get those variables to cancel. So we add equations for step 2. Once we add our equations, we should be left with only one variable, either x's or y's, not one of each. And we should be able to solve. Rinse and repeat. We take our solved variable, we substitute it back in, and solve one more time. Those are our 5 steps to elimination. Do they refresh our memories from Friday, hopefully? Okay, fantastic. So, when I take a look at example 1, I'm looking at 4x plus 2y equals 14 and 7x minus 3y equals negative 8. Do I have opposite coefficients already? No. So I'm thinking, okay, I need to multiply an equation by something in order to get opposite coefficients. But when I look here, is there anything I can multiply 4 by to get 7? Is there anything I can multiply 2 by to get 3? No. So we're actually going to have to multiply both of our equations by something. Do you guys remember learning about least common multiples way back in like elementary school? It's the smallest number that like 2 numbers multiply to have in common. So for like 6 and 4, it would be a 12, right? Because 4 times 3 is 12, 6 times 2 is 12. That's called the least common multiple. So we're going to figure out what's a least common multiple between either the x's or the y's. I like to go with something that's usually smaller. So for example here, 4 and 7, their least common multiple is 28. I don't want to go there. I'd rather stick with the 2 and the 3. Their least common multiple is what? 6. So I need to multiply my equations so that I get one equation has a positive 6y, one equation has a negative 6y. So this first equation here, let's multiply that guy by 3. And remember, I'm multiplying all of this stuff. And then my bottom equation already has a negative 3y. So I know I don't have to multiply by any negatives here. I can just multiply that by 2, and I'll get that negative 6y that I'm looking for. Everybody good on that step? I have my opposite coefficients. That is what I was looking for from the beginning. So now I'm going to add them together. Those opposite coefficients cancel out. I'm left with 26x. 26x equals 26. Now step 2 is done. Step 3 is done. Step 2 is done. Now I need to solve. Divide by 26. X equals 1. Remember, we're not done. We now have to take that x equals 1, plug it back in, do the rinse and repeat. I'm going to do 4 times my x value, which is 1, plus 2y equals 14. So y equals 5 here. We can write our answers as coordinates, as you should be doing. This would give you 1, 5. Good? Any questions on that? Okay. Take a look at example 2. It does not matter whether you do the x's or the y's. It's my personal preference on that last one that we didn't do the x's so that I didn't get such big numbers. What do we want to do here, x's or y's? Anybody have a preference I want to go with? Okay. What's the least common multiple in the y's for 4 and 6? 12. So I want one equation to have a positive 12, one equation to have a negative 12. What do I multiply these equations by? Sure. Let's multiply the top one by 3 to get 15x plus 12y equals negative 42. And let's multiply the bottom one. I have to multiply by a negative because I need that negative 12. This is negative 6x minus 12y equals negative 12. I see I have those opposite coefficients, a plus 12 and a minus 12. Now I'm going to add them together. These guys cancel. What is this? 54? So x is negative 6. Remember, plug it back in. Doesn't matter which original equation you plug it back into, by the way. I'm adding 18 to both sides. 6y equals 24. Or y equals 4. Finish it off. Write your answer as an ordered pair, negative 6, comma 4. Any questions there? Are we okay if I skip example 3 and go to example 4? Okay. No, we don't need to skip the rest. All right, example 4. Which one do we want to go with, x's or y's? Sure. What's the least common multiple for 3 and 2? Okay, so what do I need to multiply by? I need a 2 and a negative 3. So let's multiply the top one by 2 to get 6x plus 4y equals positive 36. Negative 36, thank you. Let's multiply the bottom one by negative 3. Negative 6x, there's my opposite coefficient, minus 27y equals positive 36. My opposite coefficients, 6x and negative 6x, those are going to cancel. 4y and negative 27y is a negative 23y. What happens on the right side? It goes to 0. Now, for some reason, we freak out when we see something like this. I'm showing this to you right now so that we don't freak out. How do I finish solving this? We have to divide by a negative 23, and what do we get? 0 is a solution. So if you get negative 23y equals 0, please don't panic. Please just finish your problem. Divide by the negative 23. 0 divided by anything is 0, and we can plug it back in. 3x plus 2 times 0 equals negative 18, or x equals negative 6. Any questions on those? Flip it over, we're going to do the word problems. I still think that the hardest part that we're still struggling with is setting up the equations. I feel like once we get the equations, we're good at solving, but let's make sure we got this setting up part down. So we've got 2 people, they're selling pies for a fundraiser. They have apple pies and lemon meringue pies, and we're told how many pies each person sold of each and how much money they made. The last question says, what is the total cost of 1 apple pie and 1 lemon meringue pie? What are the variables that I would need to start setting up this equation? What do x and y represent? Cost of apple pies. And let's call y cost of lemon meringue. Okay. Once I have my variables, which I always look at this last statement, the last question for my variables. Now where do I look to figure out these 2 equations that I need? Totals. Look for totals. Give me one total equation. Not x plus y equals 94. I need some extra information. Autumn? 6x plus 4y equals 80. This is how many pies Mitchell is selling. So 6 apple, 4 lemon meringue equals a profit of $80. Or a total of $80. What about for Emma's pies? So we're done there. And now I'm just going to eliminate. What do I need to multiply by to eliminate to get opposite coefficients? Let's multiply the top one by a -1. Let's get, what is this? -6x minus 4y equals -80. The elimination is super easy on this one. We have y equals 14. Why are we talking? How do I figure out how much an apple pie is? I know the lemon meringue is 14. What do I do? Plug it back in. That it does say 52. It's just terrible handwriting. I believe it's this, right? Oh, no, it's 56, not 52. X is 4. So this is $4 for apple pies. Questions? Can we just set up the other one? I won't make you solve it all, but can we set it up? I want the equations, please. Abby and Zoe work Abby works 8 hours, Zoe works 10. Their combined pay was $80. When Abby works 9 and Zoe works 5, their combined pay was $65. What is each person's hourly pay? Give me variables. Give me equations. $80 is my total for this first day. 8 hours for Abby and 10 hours for Zoe. Give me $80. Give me a second equation. $9 hours for Abby, 5 hours for Zoe, combined total of $65. 9x plus 5y equals 65. Do we feel like we can set these up on our own? Fantastic.